Today's class is about balancing chemical equation. See, why should we balance a chemical equation? Because it has to obey, chemical equations has to obey law of conservation of mass. What do you mean by law of conservation of mass? Mass can neither be created nor destroyed. It disappears in one form and reappears in another form. That is what you mean by law of conservation of mass. You might have heard the same thing in law of conservation of energy. Energy can neither be created nor destroyed, disappears in one form and reappears in another form. Same it is. So law of conservation of mass, based on that, equation should be balanced. Whatever you write on the left side, remember, whatever we write on the left side, they are called reactants. Whatever we write on the right side, they are called products. Reactants and products are separated by an arrow, and head of the arrow always points towards product. So these are reactants and these are products, because the head of the arrow is towards the products. Okay, so I wrote some of the equations. Now I want to balance it. Before balancing, these equations are called skeleton equations because they are not balanced. They have not obeyed law of conservation of mass. Now let us see that they obey law of conservation of mass. Means number of atoms on reactant side should be equal to the number of atoms on product side. The weight of the reactant should be equal to the weight of the product. Let first one on the board. H2 plus O2 gives rise to H2O. Now, how many hydrogen atoms are here? 2. How many are there on the product side? 2. As such, you don't have any problem with hydrogen. Oxygens are how many here? 2, but oxygens are 1. You're not supposed to do like this. This is wrong. This is wrong, I am telling you. This method is wrong. Because you should not change its molecular formula. Its molecular formula is what? Water. You got water. When a hydrogen reacted with oxygen, you got water. And this is prepared in the lab by Henry Cavendish. So now let us do it. H is 2, H is 2, O is 2, O is 1. For this, just to make this oxygen 2, you need to add that number in front of H2. Because whatever we have to do in the front, right? So I added 2. This 2 is applicable for both. This is applicable for both. Okay. So now hydrogens are how many? Because of this 2, hydrogens turned into 4. Therefore, I have to put 2. Now hydrogens are 2. Now what about oxygen? Because this 2 is applicable for all, oxygens have become 2. Here also oxygens have become 2. Therefore it's balanced. Simple. Now the next one on the board, KNO3, potassium nitrate, okay, gives rise to potassium nitrite plus oxygen. K's are how many? 1. K is 1. N's are how many over here? N 1, 1, just 1. N is also 1. O's are 3. O's are 3 while O's are 4. So don't touch that side. See, it's like this. It's a common balance, okay? Normal position. Now O's have become more this side. So this is a position of your balance. This is a position of your balance. Right, isn't it? This part has gone down. That means O's are 4, so this part has gone down, right? So now you have to lift this. That means you have to make this 4 possible this side. And meanwhile, you cannot rub and write 4, isn't it? Whatever you have to do, you have to do here, just for the sake of 4. They are 4, but these are 3, not too much less, just one number less. So you have to go for the next number. See, one thing you should remember, if nothing is there means it is already 1, because 1 into 1 is 1, 1 into 1 is 1, 1 into 3 is said to be 3, isn't it? That's why this is 1 here. So go for the next number 2. Now K, because you added 2, this 2 is applicable for all, because you are adding it in the front, isn't applicable for all. Now because of this 2, K's turn to be 2, so you put a 2 number over here. Now this is also applicable for all. Now n's are how many here? N's are how many? Because of this one, n's are how many? 2. N's are 2. Here also n's are 2. O's are how many? 2, 3's are 6. So it is 2, 2's are 4 plus 2, 6. Yes, it's balanced. Now coming to this way, you can even divide it like this way. Another method, PB, one is PB, other one is N and O. These are the 3 things participating in this reaction. P1, PB is available, N is there and O is there. Same way you will find the same thing on the other side. There won't be any change. You will find the same thing, right? Now we'll check it out. PB, how many are there? 1 here, 1. Nitrogens are how many? 1. Oxygens are how many? 2 plus 2, 4 plus 1, 5. 5 oxygens. This side PVs are how many? 1. N's are taken twice. Remember this one. It is taken twice. This is also applicable like this. It is taken twice. Twice. Okay. So N's are 2. O's are this. This is applicable for both, isn't it? Just now I told you, no, N's are 2. N's are 2. Same way O's will be 6. O's are 6. Now, what is the difference? Difference is with n. So let us write 2 here and make this 2. Why? Because nothing is written in front of nitrogen. Just to make 2, I wrote 2. Now this is applicable for all. Now oxygen count how many here? 1, 2 twos are 4, 2 twos are, because it's applicable for both. 2 twos are 4, 5, 6 and 7. 7 oxygens. You find 7 oxygens. Come this side. Only 6. Now what is here? 1. I already told you, no, nothing is there means 1. So not, you are not getting this answer. It is 7 already. So you put the next number 2. Now this 2 is applicable for all. So it goes for PB, it is 2. So PB is 2. Hence check it out, hence see the line, it goes up to here and this is going here. Therefore try it is going like this. Okay. So n 2 to the 4, it is n is 4. Now coming to oxygen, it is same again, right? It goes up to here and this is here. This is applicable here. Okay. Therefore 3 twos are 6, twos are. So these are 12. O's are 12. Now come this side. N's are how many? 2. But so you can make n's 4 because already got 4, isn't it? You make 4. N's are 4. Okay, done. N's are 4. Now check it out. Oxygen. Oxygen is here 1. 4 twos are, it is 8 actually. 4 twos are 8, 9, 10 in 11. But what about your PB? PBs are 2. Very clear. PBs are 2. Why don't we write 2 here? Yes. This 2 is applicable for all. So your PB turned to be 2. 2 and 2. Problem solved. Oxygen C here 2 plus 8. 8. 4 twos are 8 and 2. 9, 10, 11, 12. So this is balanced. Now let's balance the remaining equations. So equation number 4, Mg plus O2 gives rise to MgO. So now, how many Mgs are there on the left side? Left side they are called reactants. Left side reactants, 1, 1. Therefore it's 1. We have no problem with Mg. O's are 2, but O is 1. You should not write like this. This is wrong. Wrong method. You should not change its molecular formula. MgO is magnesium oxide. Magnesium valence is 2 plus, oxygen valence is 2 minus. Therefore, 2 gets cancelled. MgO is correct. But it is not, it is 2, 2 here and this side only 1. So, for the sake of oxygen, just for the sake of oxygen, you put 2 here. And this 2 will be applicable for both. So, Mg turned to be 2. 2. So 2 mg's, 2 mg. O is 2, O is 2. This one, this way O is 2. Therefore, it's balanced. Now coming to the fifth one. Okay, let's see fifth one. Cu is 1, Cu is 1. So no problem with Cu. O is 1, while O is also 1 over here. No problem with O. N is 1, but N is 2, 2. Therefore, you have to put number 2 here. I told you, no, you have to do something in front only, not at the back. So once you put 2 here, this is applicable for both. Now N's 2, okay, but these have turned into 6. Hydrogens have turned into 6. You have hydrogen over here. So you, why don't you make 3? Because 6, isn't it? You require 6. 2 3s are. So for 3 2s are 6. Now since you added 3, oxygens have become 3 because this is applicable for both. Again, same. Applicable for both. So oxygens have become 6. Now oxygen, sorry, 3. Oxygens have become 3. 3. You don't have 3 here, only 1. Therefore you have to put here 3. Just this 3 is for the sake of oxygen because oxygens are 3. You put 3 for the sake of oxygen, but copper also turned into 3. So no option. You have to put here 3. So now check it out. Copper is 3. Copper is 3. This side also copper is 3. Oxygens are 3. Here also oxygens are 3. Nitrogens are 2. Nitrogens are 2. Hydrogens are 6. Hydrogens are 6. So it's balanced. Coming to the last one, very interesting one. Very interesting one is sixth one. Just to catch hold, see there are some things, a few things to remember. You catch hold of nitrogen and hydrogen, you can simply balance it. Let us start. Nitrogen is 1 over here. Nitrogens are 3. Clearly, no, 1 and 2. 3, therefore you have to put 3, no option. Now once you added 3, this I told you this is applicable for both. So hydrogens have become how many? 9, 9 hydrogens, but you have only 4 here. So if you put a number here 2, invalid, because 2 4 it's 8 only. Already they are 9. Already they are more than 8. Therefore 1 is finished, then 2, then you go for the next number 3. Now with these 3, nitrogens have become 5. Nitrogens have become 5. So why don't we put 5 over here? Yes, very good, 5. With these 5, hydrogens have become 15. Hydrogens have become 15. So what does 3 do here? Nothing. So you go for the next number 4. Now with this 4, your nitrogens are 6. With this 4, your nitrogens are 6. Right? So therefore go for 6. Now 6 threes are, because this is applicable for both. 6 threes are 18. 4 fours are 16 only hydrogens. So therefore go for the next number 5. Now 5 nitrogens, 2, 7. 5 plus 2, 7. 5 plus 2, 7. Therefore what 6 has got to do? Nothing. So 7. Now 7 nitrogen, problem solved, but 7 threes are 21. Hydrogens have become 21. 5 fours are just 20. Therefore put the next number 6. 6 plus 2, 8. Therefore put here 8. 6 plus 2, 8, 8 nitrogens. So 8 nitrogens. With this 8, what happened to hydrogen? 8 threes are 24. They have become 24. Here also 6 fours are 24. Just I will write down like this. At this end, you can even write down also for this for clarity. What are the things participating? N is participating, H is participating, Cl is participating. N, same way you have to write down H and Cl. How many N's are here? Count 8. How many N's are here? 8. How many H are here? 8 threes are 8 threes are 24. How many H are here? 6 fours are 6 fours are 24. How many chlorines are here? This is applicable for all. If I don't write also, you should understand that whatever the number you add here, it will be applicable for all. So chlorines are 6 over here. Chlorines are 6. So why don't we put 3 here? So they become 6. Now it's balanced. Let's see next 3 more equations. Let's do three more equations. So equation is here. KMnO4 gives rise to K2MnO4 plus MnO2 plus O2. Potassium permanganate it is. Okay. KMnO4 on heating it is gives rise to K2MnO4 plus MnO2 plus O2. Now let's start. K is how many? 1. Here K's are 2. Therefore let us put 2. This 2 is applicable for all. Everywhere it is same, not new. It is same. What all I have explained previous 6 also same. Everywhere it is same. Whatever you take in the front, it will be applicable for all. Now MNs have become how many? See, I'll show you. MNs have become how many? 2. So here also one is 1 mm and plus another mm. Mn, 1 Mn, another Mn. So 2 Mn. Here also it is said that there are 2. Now oxygens are how many? Oxygens are how many? 2 4s are 8, 2 4s are 8, 2 4s are 8. Same way 4, nothing is there in front. 4, 4 plus 5, 6, 7, 8. This is balanced. Now come to this one. A little bit interesting one. Mg is how many here? 1. Mg is 1. Ag is 1. Ag is 1. But n is taken twice. N's are 2. Now n is here. Nothing else is now taken twice here. So for the sake of 2, for to make this n 2, you have to add a number 2. And this will be applicable for all. So now n's have become how many? N's 2, 2, 2, n's are 2, n's are 2. Here also n's are 2. N's are 2. See my finger, n's are 2. O's are 6 here, O's are 6, O's are 6, O's are 6. O's are 6. 2 3s are 6. AG is 2. AG is 2. So put 2 over here. AG is 2. AG is 2. AG is 2. MG is 1. MG is 1. AG is 2. AG is 2. N's are 2. N's are 2. N's are 2. N's are 2. O's are 6. 6. O's are 6. 3 2s are 6. Balanced. This is a simple one, very simple one. H is 2. So for the sake of H, you put here 2. And this, as I told you, this is applicable for both. So chlorines 2, chlorines 2. So it is balanced. Let's do the remaining two equations. NH3 plus O2 gives rise to H2O plus NO. Okay. So we have to balance whatever reaction that is written unbalanced. We call it a skeleton equation. Now it's a skeleton equation. Let us balance it. We are balancing it based on law of conservation of mass. What does law of conservation of mass state? I told you in the beginning of this video, the mass of the reactant will be equal to the mass of the product. The number of reactants will be equal to the number of products also, right? N is 1, N is 1. H is 3, H is 3, 3 over here, 3. H is just 2, just 2. So something is less here. So whatever you want to do, you have to do here. It's already 1. It's understood that it's 1. So go for the next number, 2. Now these 2 will be applicable for both, right? Now hydrogens are how many here? 3, but with these 2 they have become 4. So you need to do something here, right? Actually you're doing this for the sake, these 2 is just for the sake of what, can you tell me? Hydrogen only, because hydrogens are 4. They said they were 3. So to make this more, the next number you added is 2, 2, 2, 2 here. Okay, 2. With this nitrogens have become how many? 2. Therefore you have to put here 2. Again this is applicable for both. Now count on. Nitrogens are 2, nitrogens are 2, nitrogens are 2. Hydrogens are 6. Hydrogens are 6, but hydrogens are just 4, so you have to put here 3. 6. Hydrogens are 6. Hydrogens are 6. Nitrogens are 2. Nitrogens are 2. Now come to oxygen. 3 over here. 3 plus 2. 5. So how can you make it 5? 2 to the 4 only. So you take the next number 3. So 3 to 8 is 6. So no option. You have to change this into 3, because see oxygen 3 plus 3. 3 plus 3, 6. So 3 to the 6. With this, what happened to nitrogens? They have become 3. So put here 3. Nitrogen, see, nitrogens are 3. Now nitrogens are 3. Now nitrogens are 3. Now what happened to hydrogen? 3 to the 6. 3 to the 6. 6. These are 3 threes are 9. These are 3 threes are 9. So you cannot make this 4. If you make this 4, it will become 8 only. So you make it 5. Now tell me hydrogens how many? 5 twos are 10. So what option you have got? These are 9 now. These are 9. These are 10. They have become 10. With the next number, they have become 10. These are 9. So you go for the next number, 4. Now 4 threes are 12. So now no option for you. You have to make it 6. See now, hydrogens how many? 4. Hydrogens are 4. So change now. Now you have to change. 4. Hydrogens are nitrogen, sorry. Nitrogens are 4. Nitrogens are 4. Hydrogens are 4 threes are 12. Hydrogens are 4 threes are 12. 4 threes are 12. 4 threes are 12. 6 twos are 12. 6 twos are 12. Oxygen, see, oxygen 6 here. 6 plus 4, because this 4 is applicable for both. So 4, 4, 4 plus this is 6 is applicable for all. So 6, 10. Therefore, you make this 5. Balanced. Now we'll see the last one. Taken twice. Taken twice. So many things. Okay, taken thrice also. Last one. They are taken thrice. Now we'll check it out. Aluminium is how many? 2. You may find aluminium only 1 year. So for the sake of aluminium, you put 2. This 2 is applicable for all. Like this it is. And this O, isn't it? O means it is taken thrice. H is also taken thrice. That part is over. Now aluminium is 2. For the sake of aluminium 2, you have added 2, and that is applicable for all. Now you tell me sulfur. Sulfur, see, sulfur taken thrice. Because Al2 SO4 is taken thrice. SO4 on the whole is taken thrice. So S is 3. Where is S? Here S. So you have to write here 3. This 3 is for the sake of sulfur, but applicable for all. Applicable for all. Yes, it is applicable for all. Now start. N's are 3. Good. N's here only 1, isn't it? So let us write 3. Now this is applicable for all. Right. So let us start now. Aluminium is 2. Aluminium is 2. Sulfur is 3. Sulfur here it is 3. Sulfur, this is applicable like this, therefore sulfur is 3. 3, like this, okay, 3. Now O's are, how many O's are here? 12. So let me write down here. O's are 4 3s are 4 3s are 12. Okay, this and this one, because it's applicable like this. So 4 3s it is 12 plus. This is again 3 plus 3 it is 3. Here oxygens are 3 3. Here 4 3s are 12. So it is 15. This side let us say oxygen. Here 4 3s are 12, 12 oxygens. 3 4s are 12, or 4 3s or 3 4s are 12, 12. As this one, see this 2 is applicable like this. It goes up to here, and from here it is like this. So your oxygens are 6 here, 6. So these are 18. What happened this side? You got little less, isn't it? 4 3s are 12, 13, 14, 15 only. Therefore, let us make this as 4. Now let us check oxygens. 4 3s are 12 pakka. This is 4. This is 4. 16 only. 16. But that said they are 18. Let us put here 5. 5. Okay. Now let us check oxygen. Oxygens are, this is 5 and 4 3s are 12. 12 plus 5. You have 17. Only 17. Therefore let us put here 6. 6. Right now, let us count on. Aluminum as such did not change. 2 is 2. Sulfur is how much? 3. Sulfur is also 3. Right? It goes up to here 3. Night oxygens are 4. Oxygens, our topic was oxygen only. 4 3 is 8 is 12. Plus now it is 6. Oxygens are 6. 18. This said as such I did not change anything, therefore 18. See, 3 4s are 12, and this 2 like this, 2 3s are 6. So it's 18. Now coming to nitrogens are 6 over here. Nitrogens are 6, because here you find nitrogen 6. Here see, these 2 is applicable like this also. So 3 2s are 6. Okay, nitrogens are 6. Next, I finished oxygen, nitrogen is done, sulfur is done, sulfur is 3 this side, sulfur is also 3 this side. See, sulfur 3, here also sulfur, like this it is 3. Oxygen done, everything is done, everything, nitrogen. Now last and final hydrogen, with that it gets balanced. Let us start hydrogen. Do you find hydrogen here? No. Here 6 4s are 24 hydrogens, plus again 6 over here, 6. Therefore, they are 30 in number. Come this side. 4 2s are 8. 8 3s are 24. Plus here, oxygen is here. So already it is taken thrice 3. 3 2s are 6. Therefore, it is 30. Yeah, it's balanced. A good one it is. Thank you.